There we go. Okay. All right. So we're going to start the water cycle by breaking our diagram up into land and water. We'll start here in the bottom left-hand corner. We're going to draw a line up like that, go across the middle, and down on the other side. I did in black to represent land because water is going to be represented by blue. Now, the part in the middle is going to be the land. Now, that means water is going to occur here on the left-hand side, and water is going to occur on the right-hand side. But from our discussions in Chapter 9 about water resources, we know that water just doesn't exist in oceans or running water bodies. It also exists in the ground. So we're going to take that water and have it go all the way across our diagram. And that point at which the ground becomes fully saturated with water is called the water table. I'm trying to write very small to allow space for other things. I'd recommend if you have the ability to write a small, do so. I know some of you guys have larger handwriting, but keep it as small as you can for this, please, to allow for all things to be added. We have to have some energy present in our diagram. That's why we're going to add the sun in the top left. The rays of the sun are going to shine down onto all things, but in particular, what we're concerned with is the ocean or lake down here. I'll label things in red. So ocean / lake. So that sunlight coming down, shining onto the ocean lake is the energy that's going to drive the water cycle. And what I mean by drive the water cycle is if you take the sun's energy and have it hit a body of water, what's going to happen to that body of water? It's going to heat up, and then eventually what can happen to the water? It will evaporate. So we're going to draw some arrows coming off of this ocean or lake. And we're going to represent the process of evaporation. What would you define evaporation as? The process that does what? Anybody want to? Good. So it's taking H2O liquid to H2O gas. So we're going to write H2O and put the gas symbol behind it to show what evaporation does. That water will continue to rise in the atmosphere. And as it moves higher in the atmosphere, what is the trend in temperature as you go to a higher altitude? It gets colder. And as the temperature gets colder, as you go higher to the atmosphere, what's going to happen to that gas form of water? Good. What's that process called from gas back into liquid? It's what you call what happens on the outside of the glass. Good. Condensation. This is H2O liquid. That after the H2O, that's a cursive L to represent liquid. I'm going to put a dotted line around condensation because if you have enough condensation occurring up in the atmosphere, what forms? Clouds. Does anyone know why some clouds are white and some clouds are gray? Kind of a little trivia. Yeah. A gray cloud has more water vapor present in it, and therefore gray clouds tend to lead to what? Rain, because if the clouds get too heavy, what happens to the water in the cloud? It falls out. So we're going to show precipitation coming down. And And that precipitation is going to go down all the way to the water table in the ground. The process of water moving through the soil to the water table is called percolation. 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 That's one thing that water can do. And percolation is the movement of water through soil to the water table. Besides moving it, if rainfall hits a natural surface, it can move through the soil, or what's the other option that it has? It can run off. So we're going to draw, I'll make it blue to represent water movement. And you're going to get runoff. And usually that occurs, water runs off into streams, which then those streams will empty themselves out into larger rivers and then eventually make their way to an ocean or a lake. In chapter 9, we mentioned the term we apply to a body of water underground, meaning like a storage area for waters. And remember that term to describe water underground in the stored area? It is groundwater, but the whole pool of groundwater has a specific name. Ooh, close. Aquifer. Okay, so this aquifer right here is called an unconfined aquifer. And we call it unconfined because it can be recharged through rainfall. So the movement of water through the ground, called percolation, allows for the aquifer to be recharged. That's called an unconfined aquifer then. Now this rectangular box underneath that, it's representing a layer that is impermeable to water flow. And what type of soil is impermeable to water? Good. So this is going to be your clay layer right here. And that is impermeable to water flow. Which then means the aquifer underneath that clay layer, because it cannot be recharged by rainfall or other things like that, what term do we apply to it? Very good. Next, we're going to put a tree right here. We're going to put those roots going way down deep into the water table, drawing water from it. Make it a nice green tree. You put some apples on there if you want, or cherries, or whatever type of fruits. The reason why we're drawing the tree, though, is trees obviously draw water from the soil, and they move that water through their roots, up the trunk, to their leaves, and out their leaves into the atmosphere. And for those people, I think both regular bio and AP biology discuss the term for the process of movement of water through the tree, through the leaves, out into the atmosphere. Remember that term? All right. It's called transpiration. So transpiration is the movement of water through a plant and then out of the plant back into the atmosphere. I'm going to stop the recording because there's a 10-minute maximum on it. And I'll restart it here. So we take a little break, talk amongst each other while I get the recording started back up.